So, hello class, good morning. How is everybody? Okay, good. So, before we start, can someone lead the prayer? Who are absent today? May I know in this class? Okay, who else? Okay, so can someone in the class can still remember our last discussion? Okay, thank you, Miss Hannah. So, what can you say about reactant and product class in our last discussion? Yes, you're right. So we have here some objectives for our today's discussion. So number one is describe the concept of chemical equilibrium. And number two is to explain the significance of the equilibrium constant. And um, the third one will be the value, the applications of equilibrium in the environment. I have here motivational activity. So, part one, it is generally means consisting of parts or elements that are all the same. So, what is this? Yes, homogeneous. So, how about this one? It is a different in kind, unlike, incongruous, new word, no? So take note. And composed of parts of different kinds, having widely dissimilar element constituents. Yes, heterogeneous. So this one is the action or power of focusing one's attention or mental effort. Mental effort. Yes, concentration. It is the measure of hotness or cold expressed in terms of any of several scales including Fahrenheit and Celsius. Yes, temperature. And the last one will be it is the continuous physical force exerted on or against an object by something in contact with it. Yes, it is pressure. So these words are connected to our today's discussion, which is the chemical equilibrium. So this class will divide it into how many are you in the class? So 30. Um, this class will be having a, let's say, 6 groups. So in every group there are 6 members of it, and there will be one representative to go in front to receive the paper that I will be given to you. And then before we start, let's count off. I'm gonna count off. And then okay, proceed to your group properly. In a count of 1, 2, 3. Yes, and everyone in the group will be having a one representative to discuss what have you comprehend and understand in that context that I give to you. You 5 minutes or 10 minutes discuss or brainstorm. Um, Only one representative is going to discuss the assigned topic. So thank you all. So we were able to describe the concept of chemical equilibrium and distinguish between dynamic equilibrium. Chemical equilibrium is a state in a chemical reaction where the concentrations of reactants and products remain constant over time because the forward and reverse reactions occur at the same rate. Dynamic equilibrium is it is the condition where the rate of the forward reactions equals the rate of reverse reaction. And then the concentrations of all reactants and products remain constant. and the reaction is ongoing, no? But there is no net change in the concentration of reactants and products. While in static equilibrium is condition where no reactions occurs because the system is in state of rest or no change. So there's no exchange of reactants and products. Understand the significance of it. Um, and how is it calculated for different types of chemical reactions, even though this discussion was discussed last meeting. So this equilibrium constant is a numerical value na nag-express in the ratio of concentrations of products to reactants and out of equilibrium for a particular reaction at a given temperature. K equals to CD over AB, where A, B, C, and D are the molar concentrations of the reactants and products. And the small letter A, B, C, and D are the respective coefficients in the balanced chemical equation. So we have here applying the Le Chatelier's principle, which is you are able to predict the effects of changes in concentrations, temperature, and pressure on a system at an equilibrium using this principle. So this principle states that it is a dynamic equilibrium because it is disturbed by changing the conditions or the system responds to counteract the change and restore a new equilibrium. And adding or removing reactants in concentration will shift the equilibrium. It will shift the equilibrium to oppose the change. While in temperature, increasing the temperature favors the endothermic direction of the reaction, while decreasing the temperature favors the isothermic direction. While in pressure, changing the pressure affects reaction involving gases. Increasing gases shift in equilibrium towards the side with fewer gaseous molecules. To differentiate between homogeneous and heterogeneous in equilibrium systems, is the homogeneous equilibrium is all reactants and products are in the same phase. Um, for example, of this are the gases or liquids. Heterogeneous is it is a equilibrium that reactants and products are in different phases. For example, of that is carbon chloride. Types of equilibrium is expression for in heterogeneous that includes only the concentrations of gases and aqueous solutions to omit pure solids and liquid. So we have here applications of chemical equilibrium, no? So when it comes to industrial process, the pressure in here is high pressure that favors the formation of ammonia because there are fewer gases or molecules on the product side compared to the reactant side. So increasing pressure shifts the equilibrium towards the productions of ammonia, while the temperature or the factors given in chemical equilibrium is the reaction is exothermic or releasing heat. And according to Le Chatelier's principle, or with the um, group 2 discussion, lowering the temperature favors the formation of ammonia. However, too low of temperature reduces the reaction rate. So therefore, a compromised temperature is used to balance yield and rate. While in catalyst, iron catalysts are used to increase the reaction rate without affecting the position of the equilibrium, so allowing the process to reach equilibrium more quickly. Biological system, or understanding the metabolic pathways and enzyme activity. Um, this consists of a series of enzyme catalyst reactions. So the equilibrium principles are critical in understanding how these pathways are regulated and maintained. Enzyme reactions, substrate and product concentrations like enzymes, catalyst reactions by lowering the activation energy, or we facilitate the establishment of equilibrium between substrates and products. And then regulation, like the processes often involve feedback mechanisms where the end product of a pathway inhibits in earlier step the equilibrium concentrations of key molecules. For example, if this is the glycolysis pathways involved in multiple steps where the concentration of glucose and pyruvate is regulated to meet the cell's energy needs. So enzymes ensure that intermediates are efficiently converted and maintained at proper levels. So when it comes to environmental science, like understanding the equilibria in natural processes, this applied that the carbon cycle is involves the movement of carbon among atmosphere, hydrosphere, lithosphere, and biosphere. So equilibrium concepts helps explain how carbon is exchanged and maintained in different reservoirs. So understanding this chemical equilibrium in this context helps optimize us in industrial processes, regulate biological pathways, and it also explains the environmental phenomena. So by applying equilibrium principles, we can improve efficiency, maintain a balance in living system, and predict the impact of changes in natural cycles. Any questions from the class? If none, we can proceed to our quiz. So the quiz will be 10 items, 15 minutes to answer, or 10 minutes. Time starts now. Assignment. You're going to determine what type of equilibria, or homogeneous or heterogeneous equilibrium, that I will be going to show you, or the pictures below, and you're going to pass it on next meeting. Any questions? None so far. Okay. Thank you, class.